Okay, the next topic is combinations, numbers, and letters. Okay, have you ever seen those padlocks with a number combination? They look something like this. You have your padlock, we have this curved bar right here, which will secure your backpack, your luggage, your locker, whatever it is. And then you have numbers. You have some numbers right here. Mostly you have three set of numbers from 0 to 9, and then you have a mark right here where you can place the correct value. Basically they start with the 0, 0, 0, and then 1, 1, 1, and then they go over until they reach 9. So in total, every single row right here has 10 values. 10 values. Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many? 10 values, okay? We have 10 values. Okay, if you want to try to open it, what are you going to do? Okay, most people will try again and again and again, and they will feel frustrated because there's no way to know the right combination. Well, how many combinations are possible in this case? Okay, as you can see, if you have only one of these scrolls right here, you can have 10 values. But what if you have two of them? Okay, if you have two of them, your first value is 0, 0, and you can make combinations 0, 1, 0, 2, 0, 3, and then until you get to the 99. Okay, so between 0, 0, and 99, there are 100 values. But what if you add another 0 and another 9? Okay, that means another set of 10 numbers. So how many numbers can you make with 3 zeros and 3 nines? Okay, if you go over your first value, you can set your first value in 0, 0, 0. And then the next value will be 0, 0, 1. And then the next value is 0, 0, 2. And you can continue adding values and values and values and values until you get the last value or the maximum value, which is 999. But at this point, how many values are possible? Well, with only one scroll working, 10 values. With two of them working, 100 values. But with three of them working, we have 1,000 values. Okay? Is there any way to make it easier? Yes, of course. Well, the base, in this case, for this exponent expression or exponential expression, the base is 10, because per set of numbers, I have a maximum of 10 combinations. But I need to do this. Since I have 3, I don't have 1, I have 3 of them, I can always multiply. So 10 times 10 times 10 is 1,000. So for every number that I add to this padlock, let's see if I add another set of numbers starting with the 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the last value. So I have another 10, so I need to add another 10 to multiply. Okay? So in this case, with a padlock like this, you will have 10,000 possible combinations, all right? But our combinations are not limited just to numbers. We have also letters. Do you know any explanation, any way that we can apply this into real life problems? Okay, the numbers, combinations in safety padlocks or whatever thing that you need to keep to, whatever thing that you need to keep your stuff safe, okay? Now, when it comes for phone numbers, we have a lot of phone numbers in the US. We have a lot of phone numbers all around the world. But in this case, let me show you something. This is for the padlock. What about the phone numbers? Okay? Well, the phone numbers, if we go a little bit deep with this, you should know that there are some restrictions for certain kind of numbers, especially those 3 numbers when we start with the area code, like 214. You know this very well, okay? Also, you know this area code 972, 469, and maybe a couple of them that work for this area of Dallas or this area of Texas or even of the country. Okay, but what can they do to assign this, this, and this? Well, some of these codes are already reserved. We cannot touch them, we cannot even see them. But in the case, let's see that no one of them are restricted. All right, so you see 1, 2, and 3 values. And every value is coming from 0 to 9 because we have 10 values per digit, but we don't have only one digit, we have 3 digits. Okay, in this case, how many area codes are possible if we have no restrictions? Well, in this case, we have 000 and 999 for the last one. Again, we have 1,000 values. Okay, 1,000 values. Okay, as I told you before, we have restrictions. Okay, what if these values are restricted and for the first digit, look, for the first digit, I can have not 10 values, but I can have 5 values. For the second, I can have no more than 6 values. And for the third, I can have no more than 7 values. So what do you do? Okay, what do you do? Okay, you have the first, you have the second, and the third digit. And the restrictions say that you have only 5 values, not 10, just 5. And then 6 values and 7 values. What are you going to do with this? Just multiply. 5 values times 6 values times 7 values. So basically we have 42 times 5. 42 times 5. 42 times 5 will be 210. All right? So basically in this case we have only 210 area codes when applying the restrictions. Maybe you can think, oh, these area codes are too little. We have a lot of phone numbers. But let me tell you that we have more numbers. Remember that we have 3 more, and we have 3 more and then 4 more. Okay? So how many numbers in total can we have if we have no restrictions? Okay, to solve this, please keep in mind that per digit you have 10 possible values. Let's count all the digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 values. I have 10 values from 0 to 9, and I have 10 digits. Okay, so it's something like 10 raised to the power of 10, or using the 10 times as a factor. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then you multiply all these 10s all together. Okay? So we can use the calculator and writing 10 raised to the 10 power, or just the 10 times in a multiplication to get this number. Okay, a 1 followed by 10 zeros. Okay, it's a big number. Okay, so if we had no restrictions, we have this like the possible telephone lines. Okay, but with the restrictions, we don't have that amount. We have much less than that. Okay, but if we had no restrictions, we have this big number, which is 10,000 million or 10 billion. Okay, remember that a billion is just a number followed by 9 zeros. Okay, So basically, we can combine the numbers like this. Remember, we have 10 digits, and we have 10 possible values per digit, okay? So where do you write the digit and where do you write the possible value? Okay, so you have 10 raised to the 10, okay? So we have the possible values in the base, possible values, and we have the digits right here. When you work with just the area code, you have also 10 possible values, all right? You have 10 possible values, but you're working with only 3 digits at a time, which is 1,000, okay? But with restrictions, we can have less than that, okay? Well, I need to erase that to explain you now about the license plates, okay? How do we work with the license plates? Okay, it depends on the population of each state, how these license plates are issued to the car owners, okay? In the case of the state of Texas, if you see the license plate, is something that you have attached to the bumpers of your car, and then you have a letter, and another letter, and then you have 1, 2, 3, 4 numbers. Okay, remember, we have also restrictions, okay? Because not every word with 3 letters could be written in the license plate, okay? There are certain slang or bad words that can not be there, or anything that is referring to that we can express in 3 letters, okay? So we have some combinations that can be discarded. But thinking about that, we don't have any of those combinations out of our system. How many combinations can be done? Okay, let me explain you first with a letter, with a single letter. It can go from A to Z, okay? How many letters do we have in our alphabet? Okay, if you count all the letters that you have in your keyboard or the calculator keyboard, or you just count them all, we have just 26. And I will count you for you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 26 letters in total, okay? So per digit, I will have 26 values per digit, okay? So if I have 3, I will have 26 times 26 times 26, stop. And then another multiplication. How many do I have for numbers? You know that we have numbers from 0 to 9, which makes a total of 10 numbers. 10, 10, 10, 10. 1, 2, 3, 4 numbers. 1, 2, 3, 4 numbers. Okay, easy. All right, so there is a way to make it shorter when you have the 26 raised to the power of 3 times the 10 raised to the power of 4. 1, 2, 3, 4. We have it 4 times right here. We write the 4. It doesn't matter if you are using a calculator like the Texas Instruments calculator. Maybe you don't have it at home, but you can get an app for your phone where you can make your calculations like this using this notation. Okay, so it doesn't matter if I do the entire multiplication or I go through the the exponential expressions. Okay, so if I have 26 raised to the power of 3 times 10 raised to the power of 4, I have a very big number. All right. So we have all these possible license plates for the state of Texas. Okay? Well, if I have a number out, well, the number will be less. I need to raise one zero. Okay? So that's it for the combinations for the license plates. If you want, I can make another example real quick. If Louisiana has less population than Texas and the values are only 2 letters and 5 numbers, 1, 2, 3, 4, 5 numbers. So basically we have the same. We have 26 squared times 10, 1, 2, 3, 4, 5 raised to the power of 5, or 26 times 26 times 5 tenths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so let's do it. 26 to the second power times 10 to the power of 5. Right, so we have less license plates. Okay, in here we have almost 176 million, but in here we have almost 68 million. Okay, so this is one application for numbers and letters combinations.